right. Good morning, and thanks for attending. So yes, I'm Steve Walker. I work with InferSight Labs, and I'm excited to talk to you today about software exposure. And we'll get into what that means for me and why we're calling it software exposure. So, I'm going to need my thing to change the slides here. So, let's see. Point. There we go. All right. So, who am I? I spent lots of time on red, blue, and purple teams. I started off actually as a software developer and moved into network security. Firewall admin, network security admin. And as I defended those networks, started looking at, well, how are attackers getting into our networks? And that really interests me. So back in 2010, got into offensive cyber with the government and then moved into consulting. And that's been a lot of fun. I've always enjoyed challenges and problems, and just that consulting mindset and pace is really enjoyable. So learned a lot really quickly, and at this point, that transitioned over to, well, now that you know what attackers are doing, when incidents occur, you can be involved in incident response. So I get called into like, hey, what's going on here? I'm like, oh, if I'm seeing this means that the attacker's over on this side. So at this point with InferSight Labs, we're working on new methods of detection and response, and a lot of times it's, well, if I'm in this network, here's what I would be doing. I want to put some indicators here or tripwires here to find those things when they do occur. And that really is that overarching security program instead of just doing assessments. So software exposure vectors, let's get into introduction. So consider three major events of the past couple of years, and I'm sure you hear this all the time, don't we all? I don't have to go into detail on each one, but I'm going to go in some detail on each one. And there's a reason for it. So all of them have to deal with software: SolarWinds, Log4j, and the Russia-Ukraine crisis. Let's take SolarWinds to start with, right? And there's this high-level attack chain. You're starting off with a supply chain compromise. So obviously, actor gets in control of SolarWinds. They put in a DLL that gets pushed to all of the clients. And you, as a client, don't realize this is going on. You're using trusted software and think everything is secure. And the next thing you know, we get an alert that this trusted thing, they have access to all of your networking equipment, deep in the network. And next thing you know, they're calling out command and control to China. It's like, great, wonderful. You have this massive incident response you have to get on board with and backtrack. When did this get in there? How do we track it down? And it's a very challenging response, especially in large organizations. And take Log4j, another example where the attacker sends in an exploit string to your system, and the application itself then is processing has Log4j, processes it, sends an LDAP call outbound, which comes back to the application. It says, oh, I need to authenticate here, and it sends out, runs the command and calls back to the attacker. So the interesting thing I found in doing incident response in these environments, it took a while for a detection scan to be created for it. So on the defensive side, we're spending a lot of time writing your own custom detection before you could actually run a scan with Qualys. And even when Qualys did come out with the scan, found it actually wasn't as accurate as you'd think. They're looking for a response very quickly within a couple minutes. But what we found in running our own scan, I'd set up a listener and run it, and it could be 15 hours later when the log processor of that web application log handled it, and it was using Log4j and called back. So we'd have callbacks happening many hours after it that a scanner is not going to pick up on. So you have this latent inbuilt vulnerability that you had to deal with. And then you have the Russia-Ukraine crisis. So if you're dealing with an environment where you have work in Russia or work in the Ukraine, or you have development teams that are based there, all of a sudden with the sanctions coming on, you're having to respond quickly to, do we have concerns about our code that's based there, our employees that are based there? How do we manage that environment? So it brings up that long-term insider threat that maybe you hadn't thought of. So given those three, what's really in common across all of them? to me, the big thing we have to take away is there's lots of embedded code and embedded solutions that are involved in all of our solutions going forward. And that embeddedness is also with the people that you're using to build those services. So the question really is, how do you remediate those things? To me, it's, well, when is code no longer code? At what point, and what you should think about as I go through the talk after this introduction is, how do we get in front of the problem? In other words, where does coding stop and those security controls that we've been trying to figure out forever factor in? It's not the same as traditional security controls. So with that said, let's talk, once I go through those, we'll talk about 3 steps that I can think of to get a grip on this new paradigm. All right, so software exposure vectors. Let's talk about the ways these vectors come into play. So as an attacker, so in my background, I do offensive security consulting. I've been doing assessments across tons of networks, and I like the challenge. We were just talking before the talk. That I really enjoy just the different networks I'm involved with, and it's always a puzzle to figure out. So I get really involved and enjoy figuring out the puzzle as an attacker. In general, when I'm doing that, vulnerability scans are just vulnerability scans. It's just an opportunity. They give me an initial point of, hey, this might be interesting. And they're all potential injection points. These are different ways you could get into the network. So it informs either how good their vulnerability management policy is or the ways they're addressing things. But they're really just issues in code. And in fact, when I'm leveraging that vulnerability, when I'm trying to put something in some of my attack tools in place, it's an implant. And everyone thinks of implants as, oh, it's malware, it's something compiled that you can't really get your hands around. It just sounds bad. But an implant really is code also. It's just something that I've worked on, pre-built, that I think will get through security controls and get back to me to either do what I want it to do or allow me to control that system. And then you have, obviously, the infrastructure as a service or infrastructure as code. So when you're dealing with that, those are just playbooks and scripts that set up your infrastructure. Now you're talking with, instead of having physical firewalls, routers, switches, and being able to control those and set them up with your security team, who then has change control for all the access control lists that you need to involve in monitoring over the protocols. Instead, you have a script that sets up all your security boundaries and all the identities that are involved in that environment, and it's all just code. So you then have to try to create logical controls around them. And that becomes a big issue. So exactly the last point there, microservices and cloud networks are the same sort of thing. You're using this code to create this complex environment quickly and dynamically on the fly. And it doesn't really jive with the way I started in network security of adjusting firewalls and rules. That gets around those. And I should have said on that last slide, it also brings up, what's your biggest concern here? Your insider threat would be a big issue because they control a lot of that environment. They control that infrastructure. So let's look at infrastructure as code as an example. So you have development tools that deploy that infrastructure. As I mentioned, there's no traditional security operations. It's really, hey, I've got this script. It's going to define all the different attributes. And those dynamic changes that you can do, I got to deploy some other piece. Let me just change the Terraform script, change the Ansible playbook, redeploy it, and it's changed. That quick change misses your normal security controls. So it can carry security weaknesses. They can all of a sudden include, you're used to doing secrets within those codes, and that's one of the big things you'll scan for. Is there a secret in that playbook that we didn't take out? But what about the logical pieces of it? Is that an actual logical layout that you're putting together? So those dynamic changes change the landscape quickly. And not only that, you have to be sure, say I wanted to scan this environment that was just stood up really fast. And as an attacker or as an assessor, you're brought in, you have a scanning system that has access to what? Usually the front end of that web application, it scans it, looks for vulnerabilities. But does it have access to that middle compartment? Does it have access to the database side? And when you're doing an audit or an assessment, there's a lot of things that, okay, we're going to whitelist and create rules that allow you to get to the different systems just to be able to scan it, and you're scanning for vulnerabilities. So often, that doesn't happen, and you can't really validate it as an assessor if you do. They say that it's there, and okay, we saw nothing or only a few ports. Sometimes you can quickly figure out if, like, okay, they're putting me in a box and I can't get to things. But the point being, it's hard as an assessment or as a security defender to know where those risks are or to identify where those vulnerabilities are just by scanning. So today's code, vastly different from 10 or 20 years ago. When I went through in computer science, we didn't have any discussion on source control, didn't have any discussion on secure coding, really. And it's all now you're talking where it's, and we didn't even have GitHub. Like, oh, I can go and find this solution for this small piece of code that I need that does this, pull it into my code and build it. You don't have those when we were going up, so you didn't have any discussion of how to do that properly or properly vet those issues. It's so dynamic that really everything is code. And it presents a lot of significant challenges. Now you're pulling in GitHub repos that have open source libraries involved and which have their own license issues and concerns with them that you have to now vet and figure out, how do we deal with this license issue, that license issue? Does it mean that our solution now has to be just released and all our proprietary stuff is at risk? So you have to address those too. That brings in a whole lot of different exposure sides. Not, licensing is not just the can I exploit it. And now you have cloud-based solutions. Instead of it being on-prem, here's my web server that's running the service that I can go and exploit, it's now microservices that are around. And over time, I mentioned the dynamic deployment that, okay, I found an error in my code, let me correct it, deploy it again. And the security side, you may have missed it. It may have already been exploited, but the developers changed it, re-pushed it, and you're moved on. So you didn't even see that there was an issue there. And the last point I have there as well is mixed language environments. And what I mean by that is over time, as you're developing, it becomes it's almost like urban sprawl, where you're developing in one language, and over time a new developer comes in and starts adding on this component. It may be in a different language that now gets compiled or linked together. You have scripting languages that now set up things. I saw Terraform and Ansible just for controlling the infrastructure. There's so many code languages and pieces that you have to manage. It's really difficult to say, where is my exposure risk with this massive set of code across these different environments, cloud, local, and everything, that it makes it really difficult. So you have today, instead of a local, statically compiled system, it's disparate sources, distributed everywhere, and you have online execution of everything. So yeah, everything is code. Great. What does that mean? How do we address it? This, to me, means that developers are the ones that have the full picture of the risk. They're able to configure that infrastructure, configure the microservices, configure the identities, push all of those out, and they have the view of the full picture. On the security operations side, when I'm working with those teams, it's very difficult because we're trying to figure out, and we all often say, I need more visibility to this system or this environment. And what we're really saying is, I don't really know what your software does or what the solution really is at a high level. And so the only response is, let me get more access or have more insight into the ways that I can plug in the security things that I know. What happens when that key risk, that key developer, a key man risk, leaves, goes away, or is now considered a threat, or is compromised in a way? Then you have this whole environment that you've built is now at risk. And your security team is left not knowing what they can do to fix it. So it is a really big, significant challenge when developers are the only one with the picture, with the full picture. So if everything is code, I couldn't resist putting in a matrix reference, right? Everything is code. It's a construct. And so when I heard, and it came to mind of construct, I went, oh, well, there's a matrix reference. So I got to put a picture in there. So if security operations is now a framework, a construct, how do we factor that in? How do we factor security operations now into such a difficult dynamic environment? And physical networks and systems are really just conduits for that. It's really crazy, and you'll see in my next slide, like you set those up, and those boundaries that you're rolling out, that the developers roll out, or that you have this dynamic environment rolling out, they're really just setting up and enabling them versus being a way to control them. So this is a really terrible diagram put together, but wanted to drive home the point of what is a physical network and how these dynamic environments really change the perspective. You've got what we would think would be a control of firewall, corporate network, access control lists. We allow this system and this DMZ to talk out to these systems or to talk internally to this database server, and that's how we know and have a network diagram of the environment and what the operational flow is. However, in today's dynamic world where you can stand up a microservice in AWS or Google Cloud and then have all of the identities played up and then have the connections all set up already, it can subvert all of those controls that you have in place and your change control windows. That big pipe I have in the middle is in highlighted dynamic. You have dynamic VPNs and security groups that can be spun up on the fly. And by dynamic VPNs, I'll put a call out to Tailscale. It was a great example of something that, as an attacker, I love. It's its own command and control framework. I install Tailscale or have it running as a service on my implant or even microservice, right? It has its own way of getting out of a network. It will subvert and switch between different connection types just to connect back to its VPN. And then me, as my laptop sitting somewhere, I connect to the Tailscale network, and it's right there. It's adjacent to me, logically the same. So instead, I'm just connected. I'll run my implant, which now it's connected to me locally. I can do whatever I want. It's based on WireGuard, so it's just this super fast pipe between the two systems. And so by running something like that, I use it as an example. Your development teams and cloud-based systems can subvert those security controls you have. And as an attacker, it's great. So how are you supposed to get around that when you have this ability for development teams to just subvert? You know what? I want to run this Tailscale network piece, and I can run it over here, and now I can do whatever I want to the database server. And even though the controls aren't there, it managed to get out of my network. I've been on a few client networks where they're like, hey, we're going to send you this box for our assessment. Okay, we'll probably have to allow outbound traffic. What's the outbound server you're going to talk to? I'm like, well, let's just see if it gets there first, and then we can get to the change control to whitelist it. And quite often it just calls out, no big issue. Okay, so now that we've talked and I've scared you a bit, what do we need to do about this? Traditional approaches, code scanning, scan all the things. It has its place. It definitely has its place. Still, you have code scanning that still comes into play. You have StoneRCube for coding weaknesses, or Black Duck for dependency analysis and license analysis. Those have their place. You still need to have those license risks you have to track, and there are solutions for that. And you have, on the GitHub side of commit blocking, of if it fails some security check, or you roll out the solution and it fails in some way, like, oh, the code has extra white space even. I've had code commits rejected for that. At least you can have some control there of your code and know that when it's committed, it's secure, or at least follows certain standards, and it's going to work. And then, of course, the vulnerability scanning piece, which we talked about. And you can go through secure code training and have a change control process, but as we've seen, there are operational challenges to this, and we have to address those differently. So, make it actionable, 3 steps to address this exposure risk. And I don't go into a lot of detail on them, but there's a lot that could be written and said about these. So I just pulled out these 3. First, develop threat profiles, then worry about the visibility. As I mentioned before, on the security team, our response to trying to secure these dynamic environments is, I need more visibility. But really, you need that threat profile first. You need to know how attackers are going after that environment. Sit down with your attack team or a consultant red team and collaborate on those attack ideas. the red team, if I'm coming in blind to an environment, I don't know how it works. I can't tell you how I would go after it, but if you sat down with the developers, those that know the system, and just talk about how does this work, what is the system supposed to do, how does it talk through the operational flow of it. And as an attacker thinking differently, we might come up with some different ideas. Here, if I was an attacker, this is what I would do. And that collaboration usually spawns into here's some really great profiles or concepts that we can use. This is how an attacker could leverage our system to do bad things. Great. Find those few profiles, and then once you have them, all right, if I'm supposed to detect that profile, what code or what data do I need to identify it? You don't need to log every single event log to get that data. Maybe it's just I need the access logs from Apache, and I need the login data from whatever identity provider you're using, and you combine those two to look for the specific credential stuffing or something. So have that logging match the profile, so it'll be much more cost effective instead of just, I need more space for logging, I need to pay a lot more to log everything, because that just makes more noise for your guys to work through and figure it out. It's just lots of noise instead of being focused on specific reasons why you need it. And then that enables searching and automation. So Splunk is great, and Elk is great, and you can even use simple grep commands, but as long as you can automate that search, like you know what that profile is, and you know what data you're looking for, and now you have it in the store that you can access, you can address that profile. So profiles first, then get the visibility on that data. And second, collaborate, don't isolate. Honestly, I was coming from the security operations side, and you don't realize that you're missing out. As I've put this talk together, I realized in many situations, I'm talking to development teams like, I'm trying to get data, we're asking for visibility. We don't know how to ask for that. So help me help you. And really, what we're asking is, what are you concerned about? What are those profiles? Let's collaborate together and come up with a way to respond when that would happen. What are the active response options we have? And as a defender, we're thinking firewall, blocking IPs, isolating the system. But as a developer, at the code level, you have much more dynamic and very targeted controls that you could put in place. You could isolate that microservice, or you could tear down the whole microservice and spin up a new one the moment it saw something. They can do a very targeted response. So knowing what those responses are and those capabilities are is key. If you have that, like here's the profile and here are response options to that, that's a much better position to be in. So how do you break down those barriers between security operations and the development teams? And the key thing to me is bringing in DevSecOps into those stand-up calls, into your daily calls and call trees. So hey, we're having an issue in this environment. If the developer is right there and feels part of the team, they can quickly respond, here's how we'd go after it. Here's how we'd solve that problem. And number 3, build use cases and risk-based alerting. So threat profiles naturally lead to these alert concepts or scenarios, right? If they say, here's how I'm going to attack the thing, all right, well then how are we going to emulate that attack? What does that look like? The data is likely to span a lot of containers and log sets. We've got to automate those searches to bring those together. But as you have that use case, and then the risk-based alerting is, okay, here's the specific scenario we're concerned about and what the risk is. You can write a search that's going to find that piece instead of being some alert of something occurring on this one system. It's here's my threat profile. I see indicators of this specific profile, and we've already developed the playbooks of how to respond to it. And then we're going to integrate that response. So like I mentioned, since you're collaborating with the dev security teams, you have that response option to get involved and integrate that alerting into the development process. As you integrate, you need to continually refine them. So that validation and testing. You have what you think is going to work. You have the integrated response that you have tie-ins to the development teams to change it, but then you can have a red team or a offensive team in place. They can go and validate those controls are in play and then emulate the threat specifically. That way you can tell this is what it actually looks like when we're under this attack. Is it capable? Are our defenses sustainable and able to handle it? So that cross-functional exercise will help you keep those profiles updated. It'll change as that dynamic environment changes. You need to update the searches around that too. So I'm flying through my talk, but that's okay. Jump to my summary slide. So exposure vectors have evolved, and so often security teams are outside that viewpoint. And with development now being so dynamic and complex, it's a different environment. So we need to embrace security operations and DevSecOps together. And again, the 3 steps that I think to integrate that security: developing those profiles and visibility, being more collaborative between the offensive team, the offensive development and security teams, so that you can actually build the profile and ways to respond, and then build those custom use cases, scenarios, hunt for it, validate them over time. As the thing changes, as your solution changes, it's going to keep security in the forefront, instead of it being, we just have this construct and then don't have really great feeling that we have a full grasp on what the concern is, or what the risk to our true environment is. And with that, with a lot of time to spare, I'm at question and answers. Go ahead, Mark.
A little bit complex. Can you go to this slide before, actually?
Yeah.
So I like your 3 steps there, but I'm thinking, okay, a lot of developers, no time, I'm already late. You're trying to get them more involved in the process. So my big question is, have you worked with some places or some clients as you're consulting where they do have the security advocates, ambassadors, whatever you want to call them, champions, where there's an embedded person that cares a bit about security in that team? Does that really facilitate that type of thing happening? So you have a person to focus some education towards that now can start to speak a little lingo both sides, so they don't say MITRE attack framework, what?
That's right.
Yeah, because you're not going to tell all the developers that kind of detail.
That's right. And I think I did skip over that. I did have it in the past slide of the MITRE attack framework as well. It's a key point to enable you to talk at a high level to executive, and then also down at a low level to developers of here's what the specific technique is and how it would be leveraged. And the developer usually catches on to that. Oh, this wouldn't work for this reason, or it would work for that reason, and they start addressing it. But it is, in the different clients I've worked with, it is helpful when you have an advocate at the developer level on the security piece. That DevSecOps is a thing. It's not just security operations talking straight to developers. There is that piece, that translator, or someone that cares for both, and can help integrate some more, especially when you're talking about multiple different development teams. So you have someone that is a liaison between all of them, and they have, I guess, that clout with the development team of, we're on your side. And that really is the key, I think, instead of it being, oh, it's just that security team again, and they're just trying to get into our things and figure out, have access to all the data, and they want, admin access to everything, and it's just a pain. Instead, we're trying to address these specific issues or this particular risk that they're aware of. So that's, having that advocate facilitates that discussion a lot more, and actually leads to where they're involved in that daily stand-up. It's usually that person that you're interacting with most, and that person or group of people that you're using to a response. Like, hey, this product's getting attacked. They know the right person to go and grab and enact that playbook. So, any other questions? Yes, sir.
Yeah. So, great framework. To me, a lot of it is, I'll say it's like system level testing. Unit level testing.
Mm-hmm.
But we also have problems at the system level. So I start thinking about architecture. And so maybe some thoughts about, and these are all weaknesses until they become vulnerabilities, and making sure the weakness doesn't become vulnerability. Any thoughts about at the architecture level or system level on how we would apply this, where you've seen it done well?
Yeah, and I think that makes sense. So, question being, we have a lot of unit testing that's in play today, and more common, right? I mentioned the code validation side. Like, here we're doing these unit tests, and you can automate a lot of that piece. But what about the overarching issues, system level wide, or like, here's the full solution, a weakness in that solution? How do you prevent that from becoming instead of just a weakness, now it's actually a vulnerability that enables a threat profile? And that's really what I'm trying to speak to as well. I feel like the unit testing and those specific focus things are ones that we can address today through most of the time. You're doing vulnerability scanning, developers are doing secure coding, you're looking at those small pieces. You've got some links on that small piece. But when they all come together and it's quickly changing, how do you address it at a strategic level? And those are ones where it's hard to catch on flight, and that's why you can't do a scan to find it. You can't have a security team just looking at the data is not going to find it unless they understand all the pieces of the puzzle. So that's where, to me, it's knowing that collaboration with the team of how does it work, how would threats target it, and then let's see if you can actually do it and block those off. Come up with creative ways to do it. It's not like you need this specific control to fix it. It's more of, here's what it looks like in our environment, and here's what we can do to address it just by trying to do it yourself. Hopefully I answered your question.
Are you talking about threat modeling and simulation when it comes to seeing the impact on the system level?
Yes. He asked if I was talking about threat modeling and simulation when it comes to impact at a system level. And yes, to me, of course, I know I'm coming from a developer, engineering now. I've been in offensive security for a while. I always fall back to that, right? But to me, knowing what the impact is, that whenever I did an assessment, it's always about what's the impact to this? Why should I care about this specific issue? If you tell somebody you've got broadcast poisoning risk on your network, that doesn't mean anything. If I tell somebody, I use that broadcast poisoning risk to now quickly get your domain admin who was using it to connect all these shares, I have access to your whole network at this point within 2 minutes of being on the network, then they care. So the emulation piece is key to me. And by knowing what profile, what threat you're trying to, you're most concerned about, having your red team or offensive team going after it to say, does this really apply to us? What's the impact if they're successful? And how do we limit that or be able to break the attack chain in various spots? Go ahead.
Feeding off all three of you, so being threat modeler too. Getting the discipline through threat models as far as the early architecture really set the stage for over the lifespan of getting it right and helping the attackers and this defense, internal defense later, but it also helps to get developers on the track to understand the moving targets. And I've actually found when I do threat models, I joke, but every time I do a threat model with any team, there's always one aha moment when there's some connection, cloud, service, something that didn't even know they used. It's like, that's external? Are you serious? They literally, the people in the room, I've never found a single threat model where the team involved in the architect didn't have I didn't know that moment. So getting them started down that road, when they get to you, they're getting more aware to have that discussion, and you can turn and use that threat model to your advantage now, and it makes your looping better to contain this, but proactively, it I think sets them on the course to preventing some of the logic flaws, right? The only threat models are easily can identify.
That's right. That's right. Yeah, when I first started doing consulting on the offensive team, so often you're going into a cold environment, you're going black box, you don't know what's going on, and the team knows you're coming, and so they're wanting you to fail as well. They're trying to defend it. So it's always this fine line of not wanting to call someone's network terrible, and at the same time, here are the issues. So you got to point out things that they're doing right, things they're doing that could be improved, and then the problem is it's still this adversary mindset. The best successful stories I've had are ones where they embrace the team coming on board. And it's not, the red team side it really is adversary. You're trying to evaluate, detect, and respond capabilities, not the issues. The pen test side, or the assessment side, and even this security operations building programs that we do today, is best when it's collaborative. It's, hey, I'm trying to understand the risk to the environment, and I can come in and emulate a threat for you, but that's not, it's a piece of what that program building is. I'm not coming in and doing just an assessment, here's a report, now we're out. It's more of, let's talk about what the risk is, what's the threat that you're really trying to address. Let me figure out what that would look like, and by doing that, you're building rapport with that team. And then by doing that, it's a real true team effort, and now you have these great response options against that because the developers know those issues.
So are you saying for the CISO that the structure of security
So, for example, governing DevOps with security is just ugly, right? Because you have the developers on one side want to get product to market as quickly as possible, right? Get sprints. And
Right,
then you have
developers
security
doing
saying,
sprints.
these sprints might introduce exposures, vulnerabilities into the system, but then CISO has this problem, right? Has
Yeah, there's,
goals of security, but not development. And so are you proposing from the collaborative view that SecOps then becomes, DevSecOps becomes part of overall global security? So you have enterprise, product, from a one vulnerability management program. And does it work? And what have you seen?
that's a good question. So you made a good point that development teams are working on their own sprints. They're in a completely different organizational structure, usually, from security. And so this DevSecOps thing it's a hybrid. And how do you get past the different organizational challenges of those two? Would that be fair to say? And to me, guess what I've seen so far in the different environments I've been in? The ones where you're most successful are one where the development teams are already talking to security teams. They have this mindset of here's how I have to address security. Having that liaison that we talked about before, but that has that mindset. They're helping review. They know that security is involved just to double check quality control side of things. And usually, it's really the DevSecOps piece. To me, it helps a lot when they are part of the security team. They have the teeth to respond of, look, security is key, and everyone's heard security is key, secure coding is key. But when you're involved in the operational side, instead of it just being, I'm helping make sure your code is secure or this environment is secure, you're now involved with the threat side as well. You know what threats are coming. You know when we're under attack, and that DevSecOps person is part of that talk instead of being still more developer side focused. If you pull them in on the security side, they have visibility. They don't have visibility in security too, so it does go two ways. So once you give them that also helps pull security more into the development side as well. Cool. Yes, sir.
So you talk about the threat profiles and mapping it to MITRE ATT&CK, and maybe you've identified 2 or 3 techniques or sub-techniques that you want to go after now that you figure out that it's true. Are there good sources, like good design patterns or good places? I mean, is it just the OWASP and go back in there? Or I mean, what have you seen about attacking, filling that gap, getting in the threat?
So you have a threat profile, and you've identified multiple vectors, or maybe 3 or 4 specific techniques that these are ones we're concerned about. How do you go and emulate them?
Well, no. So now you want to go back to the developer as part of the collaboration and say, this is the design pattern you need to follow to mitigate that technique.
Oh, I understand. So going back to the developer, they're aware of these issues. Here's the controls
We all
piece.
agree that there are issues now. Now how do we solve them?
Now, how do you solve them? Well, I guess at the high level, what comes to mind immediately is on the MITRE ATT&CK side, they have mitigating controls that they kind of recommend and the references you can go to of, all right, if this is it, here's what I need to go to mitigate it. And it's going to be different in each environment. But if you've set it up in the right way that they are concerned of security, they're involved and they're seeing the attacks come in, then talking through it with them usually it just has better results. Like they feel part of that team instead of being, oh, now I'm being told I got to change my code because of something. So at a high level, I guess that's what I'm thinking. That integration piece plays off a lot. And when they know what the profile they're facing, instead of being, oh, you have this risk for, I'll say SQL injection, but I mean, that's a big one everyone knows is bad. But when you can say, this technique leads to this, that resonates better. You're able to say, if this is in play, this means this threat profile of a threat actor getting access to all of this PII data. That's a little bit different, and they feel part of the solution instead of being part of the problem.
One area, though, it's between a little bit gap what you're talking about. You're leaning towards architecture. So
Architecture.
Some of your questions. So you can have flaws there. So sometimes going to developers who just are following a pattern, giving to architecture, leads to a problem. It's not them encoding, right?
Right, yeah.
It's
Oh,
back
yeah, it's
to
a good point.
design. It's back to architecture, maybe central component management or centralized actual design. So sometimes you have to go back upstream, walking with developers, understanding where they got this approach from, this flawless identity and access management, which is nothing about their code. They're using a service they were told to use.
That's right.
In design, it's like, why are you telling me I do this, right? Sometimes, why are you telling me I have a flaw? I have nothing to do with this. I'm using the standard thing. They told me to use it.
they told me to use this
You have
playbook to
walk-
roll this out.
You need to partner with them and go upstream and say to the architect, wake up, you need to learn security too. And ideally you have a security, the same kind of inroads and ambassadors in the architecture to steer that part of the ship.
Yeah.
That's an earlier fix that it floats more boats, right? You
And-
fix it once in architecture, you might get dozens and dozens of apps now on the right path, right?
And that's that collaborate, don't isolate one that I was trying to get at. It was developers may know what they're doing when they're defining those environments, but the security operations team who has training in all of it, we feel in the dark a lot of the times, they're available, and if you are collaborating, they're able to help with that piece. Like, I enjoy the problem set. It doesn't matter what I'm solving. So while maybe I'm working in firewalls, dynamic firewalls are just as interesting and challenging. I mean, if you're working with the developer and they're going, I'm not really sure this is what they told me to use, and I roll it out, well, have someone on the security team as part of that, coming in alongside of them of how to deploy it properly, or at least evaluate what's in play. I mean, the code scan's not going to find out if you rolled out this microservice properly, or that this infrastructure as code playbook is correct. You need someone that has that skill set. And the only way you're going to get there is collaboration in the threat case piece versus some solution or a scanning piece or training even. I mean, there's a lot of training that goes into it, and you want them to specialize. There are developers in this area. You are going to have cloud infrastructure engineers too. But I guess just like in getting up here and speaking, you have this imposter syndrome of what I'm going to talk about and do I know everything? The quick thing is you realize I don't know everything, but that's okay. You know enough to be aware that there's more to learn. And that's when you have someone that can appreciate that, like we were talking before the speech here, that's an asset to me. When you're able to say, I don't know all these things, and I'm willing to learn. If you have a team that is collaborating, they're going to embrace that, and you're going to get much better results out of it. All right. Any other questions, comments? Cool. All right. Thanks for all those questions and discussion. I appreciate it.